Welcome. In this video, we're gonna compute the following sum. That's very famous, and I am assuming that everyone knows that this sum exactly. So it's 1 plus 2 plus 3 up to n. So this sum is given by the last term times the one coming next over 2. So we know the proof of this one. Okay, so we can do a quick proof, the traditional one, but today we're going to use polynomial to find this sum. Okay, let's define p of x as ax squared plus bx plus c. So we wanted this one to be a second degree polynomial. That's why we impose this condition a different from 0. Okay, so we compute p of x plus 1 minus p of x, and from there we'll see what we're gonna do. So let's do that. So in this expression we're gonna switch to x plus 1, and we get ax plus 1 squared plus bx plus 1 plus c minus ax squared, this is px, minus bx minus c, and when we do the addition, the c is gonna go, and we have a x plus 1 squared minus x squared plus b x plus 1 minus b minus 1, sorry, and c plus c, which is 0. So we have in fact we have, so if we do this one, we're gonna get 2x plus 1. That means we're gonna have a times 2x plus 1 plus b times 1 plus 0, since c minus c is 0. So we're gonna have 2ax plus a plus b. So this is our evaluation for this two. Okay, so we're gonna use this one repeatedly, and we're gonna see what we have. So now, taking x as n, we have p of n plus 1 minus p of n. So we have p of n plus 1 minus p of n. It's gonna be 2an plus a plus b. And next we do pn minus pn minus 1. It's gonna be 2an minus 1 plus a plus b. And next we're gonna do pn1 minus 1 minus pn minus 2. It's gonna be 2a and minus 2 plus a plus b. We keep going until p of 1 minus p of 0. We're gonna get in this case we're gonna get a plus b. Okay, because in our case here, this is this is 1. So in our case here, n is gonna be 0, and 0 multiplied by a is gonna give us 0, and we are left with only this one. Okay, doing addition here, we add all these numbers on the left. This one is gonna go with this one. This one is gonna go with this one. This one will go with this one here, and the p1 is gonna go with p1. So we're gonna be left with only pn plus 1 minus p of 0. Okay, so we have the left side. The right side is gonna be how many a plus b we have. So we started from n and we stopped at 0. So we did n plus 1. So we have a plus b n plus 1. And here we have 2a times 1 plus a plus b. So we have n. So on the left side, on this side here, we have 2a times n plus n minus 1 plus n minus 2 up to 1. Okay, so now what we have is we can see that this sum n plus n minus 1 plus 1 plus a plus b n plus 1, so this is our sum. We're gonna call it s, 2a times s plus a plus b n plus 1. Now we're gonna evaluate this one, so we get a n plus 1 squared plus a n plus b n plus 1 plus c minus p of 0 equals, so p of 0 is a c. Okay, if you see that p of 0 is c, we're going to cancel it with this one. So we have 2as plus a plus b n plus 1. And here we're going to see that we have we can factor this one, 2as plus a n plus 1 plus b n plus 1. So b n plus 1 is going to go with this one. Okay. And the a n plus 1 will take it to the side. So we'll have a n plus 1 squared minus n plus 1 equals 2as. Okay. So now, since a, let's first simplify this one. So this one is gonna give us n plus 1 squared minus n plus 1. So it's gonna be n plus 1 times n plus 1 minus 1. Okay, you see, if we factor by n plus 1, we'll get n plus 1 minus 1, which is n times n plus 1. So we have, in this side, if we keep writing this one in this side, so we're going to get 2a times n plus 1 equals 2as. Sorry, not 2. There is no 2 here on the left side. So 2as. We said a is not 0, so we're going to cancel by a. We get 2s is n times n plus 1. And therefore, we see that s is n times n plus 1 over 2. So this is the proof for this value that we are looking for. Okay, it's a bit messy, but it's not that messy at all, since we are doing algebra and we're learning by hand, so we make mistakes as well. So start from here, compute px plus 1 minus p of x, and keep working. Make this difference, pn plus 1 minus pn, pn minus pn1 minus 1, and p until p of 1 minus p of 0. Okay, and now collect these sums. Collect these sums on the left to get only this one, and collect these sums. Make sure that you did how many steps you did here, and steps, and equate everything to get this result. This is a proof of the result that we want, that the sum of these numbers is equal to n times n plus 1 over 2. We can do a quick proof that everyone, I think, knows, is that we can write the same as we start here from 1. On this one, we start from the end. So it's n plus, what's the one here? N minus 1. What's the next? N minus 2. And we keep going until 1. Now we do the addition. So we have s plus s is 2s. And we have n plus 1. And n minus 1 plus 2 is n plus 1. n minus 2 plus 3 is n plus 1, and the last one is 1 minus 1 plus n. So how many times we counted n plus 1? It's n times. So in this case, we have n plus 1 times n, and to get s, we just divide by 2 to get the result that we need. This technique here for the polynomials, it's very useful. So in fact, if we want to compute t as 1 squared plus 2 squared up to n squared, which is equal to n times n plus 1 times 2n plus 1 over 6. Okay, so we use a polynomial of degree 3. So let's call it q of x, a x cubed plus bx squared plus cx plus d. And we do the same work to get this one. We can also do it by induction, but try to do it like this way. Thank you.